In this chapter, we shall discuss the probability of an event and its formulas. In this particular video, we shall cover the basic formula of probability and the different operations on events that are needed for the understanding of the succeeding formulas. So what is probability? Probability is the likelihood that a certain event will happen. The probability value may be written in relative frequency form or a value from 0 up to 1. This means that probability cannot be negative or it cannot exceed the value of 1. Now, instead of relative frequency, probabilities can also be written in percentage form. This means that the value could be from 0% up to 100%. Or, instead of relative frequency and percentage, probabilities can also be written in fraction form, in which case the numerator must be less than or equal to the denominator. So this means that the numerator cannot exceed the denominator, or the numerator cannot be greater than the denominator, because this will give us a value of probability that would be greater than 1. Now here are the basic properties of probability. As from the definition, the probability of an event capital A denoted by P of A is always from 0 up to 1 inclusive. Also, the probability of the null event empty set is denoted by P of empty set is 0. Recall that the null event is an event that is impossible to happen. Third, the probability of the sample space S denoted by P of S is always equal to 1. Here is the first formula for probability. We call this formula the priori probability or theoretical probability. Let capital A be an event. The probability of A is given by P of A equals small n over capital N. Here, small n is the number of elements of the event A, and capital N is the number of elements of the sample space S. Sometimes these small n and capital N are already given or can be read from the probability problem. However, in some cases, this small n and capital N may be solved using counting technique formulas that you learned in the previous chapter. Let us illustrate the priori probability formula. A coin is tossed twice. What is the probability that at least one head occurs? Before one solves a probability problem, it must be clear what is the statistical experiment and what are the elements of the sample space. Now in here, the sample space consists of the elements head, 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 and tail, tail. So this implies that capital N is equal to 4. Now, the event or the probability of the event that we're looking for would be the elements with at least one head. So let us let event A be those elements of the sample space that contains at least one head. And these are head, 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 tail, and tail, head. This implies that small n is equal to 3. So therefore, using the priori probability formula, which is small n over capital N, the probability is 3 over 4, or 0.75, or in percentage form, it is 75%. Now let's have another example. A mixture of candies contains 6 mints, 4 toffees, and 3 chocolates. If a person makes a random selection of one of these candies, find the probability of getting a mint. So the sample space in this experiment would consist of all the candies, while the event A would consist of all candies which are mints. Now in this case, capital N is equal to 13 because there are 13 candies all in all, and small n is equal to 6 because there are only 6 mints among all the candies. So the probability of A in fraction form is small n over capital N, which is 6 over 13. Let us have a slightly challenging problem. If three books are picked at random from a shelf containing five novels, three books of poems, and a dictionary, what is the probability that two novels and one book of poems are selected? The experiment here is to select three books from nine books. So our sample space would be the set of all three book combinations. And in this case, the total number of ways of selecting three books from nine books is 9 combination 3. Now, the event A is the event that consists of all three book combinations that would consist of two novels and one book of poems. And in this case, small n is the number of elements of event A, which is 5 combination 2 because we have to select two novels from the 5 book of novels, and then multiplied with 3 combination 1 because we need to select one book of poems from the 3 books of poems. And then we can also multiply it by 1 combination 0 because this is the number of ways of not selecting a dictionary or not selecting the dictionary. So therefore, the probability of the event A is small n over capital N, which is 5 combination 2 times 3 combination 1 times 1 combination 0 over 9 combination 3. You can just use your calculators to determine the exact answer. Let us have another example. If a permutation of the word white is selected at random, find the probability that the permutation begins with a consonant. The sample space of this experiment would be the elements that would consist of all permutations of the letters of the word white. Now, the number of elements of the sample space is 5 factorial since all the letters of the word white are distinct. So this is equal to 120. Now for the event A represents all the elements that consist of permutations beginning with a consonant. In this case, small n will have a product of 5 numbers. So we shall use the generalized multiplication rule. Now in the first position, the requirement is that the letter must be a consonant. So the only choices would be W, H, and T. So we only have 3 choices for the first position. Now, for the next 4 position, we can choose any of the letters, any of the remaining letters. Since one letter is already in the first position, then there's only 4 letters left to choose from for the second position. And for the third position, since 2 of the letters were already used in the first 2 positions, the third position will have 3 choices left. And then we have 2 for the fourth position and only 1 choice for the last position. So getting this product, we get 72. So therefore, the probability that the permutation begins with a consonant is 72 over 120. Now this time, let us illustrate priori probability using a contingency table. A contingency table is a table of frequencies that is based on 2 criteria. For example, a random sample of 200 adults are classified below according to the criterion gender and criterion level of education attained. As you can see in the table are the frequencies. And in this case, the sample space is the set of all 200 adults and therefore capital N is 200. If an adult is selected at random, what is the probability that the adult is a male and second has reached up to elementary level only? So we shall base our probabilities from the contingency table. Now let us let N be the event that the adult selected is a male. So therefore, for the first question, we have P of M equals small n over capital N. Now small n is 88 because there are only 88 males out of the 200 adults in our sample space. So the probability of M is 88 over 200. For the second question, let us let E be the event that the adult selected has reached up to elementary level only. Now, using priori probability, small n is 83 because there are only 83 adults who has reached up to elementary level only out of the sample space of 200 adults. So therefore, the probability of E is 83 over 200. Before we move to the second formula of probability, one needs to know how to operate on different events. Now, these operations are similar to the operations that you learned about sets. So first, let's have the event operation union. The union of two events A and B, denoted by A union B, is the event containing elements from A, or from B, or from both. For example, let us consider the experiment of tossing a coin twice. In tossing a coin twice, the elements are head-head, head-tail, tail-head, and tail-tail. Thus, it contains four elements. Now, let us let capital A be the event that the outcome has exactly two heads. So, in this case, event A contains the element HH or head-head, while event B be the event that the outcome has exactly one head. So, in this case, event B contains the elements head-tail and tail-head. So, therefore, the elements of the union of A and B would be the set containing head-head, head-tail, and tail-head. Now, the next event operation is the intersection. The intersection of two events A and B, denoted by A intersection B, is the event containing elements from both events A and B. For example, let us consider the experiment of drawing a card from a standard deck. Let capital A be the event that a card drawn is red, which means that capital A contains the cards that are heart cards and diamond cards. And let us let capital B be the event that a card drawn is a face card. So this means that capital B contains the elements Jack, Queen, and King cards. Now what are the elements of A intersection B? In this case, A intersection B contains the cards that are King of Hearts, King of Diamonds, Queen of Hearts, Queen of Diamonds, Jack of Hearts, and Jack of Diamonds. The next event operation is the complement of an event. The complement of an event A, denoted by A prime or A to the C, is the event containing elements from the sample space S that cannot be found in the event A. So for example, if the experiment is rolling a die, the sample space would be 1, 2, 3, 4, 5, and 6. Now let's say that A is the event that the outcome on the die is an odd number. So this means that the elements of A would be 1, 3, and 5. Now therefore, if we get the complement of the event A, this would be the elements in S that cannot be found in A. And these are the numbers 2, 4, and 6. Now let us have another example. Let us consider the experiment of tossing a coin twice. In this case, the sample space would be head-head, head-tail, tail-head, and tail-tail. Now let capital A be the event that the outcome has at least one head. So this means that the element or the event A has the elements head-head, head-tail, and tail-head because these elements or these sample points contains at least one head. Now the complement of the event A would be all the elements in the sample space S that cannot be found in A. But this is only the element tail-tail. Another definition that would be needed in the next formula of probability are mutually exclusive events. Now, two events, capital A and capital B, are mutually exclusive if the intersection of A and B is empty. So this means that the event A intersection B is impossible to happen. For example, let capital A be the event that a card drawn from a deck is red, and capital B be the event that a card drawn from a deck is a spade. Are the two events mutually exclusive? The answer here is yes, because in a standard deck, it's impossible to get a red spade card. Now you have learned about the basic formula of probability and the different event operations that will be needed in the succeeding formulas of probability. Now in the next video, we shall discuss the formula for the union, for the probability of the union of two events, and as well as the formula for the probability of complementary events.